In this lesson, we're going to take a look at the key features of quadratic relations. So first, we're going to take a look at some terminology. So the shape of a quadratic relation, when it's graphed, it has a U-shaped curve. That is called a parabola. The turnaround point of a parabola, it's got both an x and a y value, so we have coordinates for it. This is called the vertex. And the vertex is going to be either the highest or lowest point of the parabola, but when we're talking about it being the highest or lowest point, the maximum or the minimum, we're talking only about the y value. So the maximum or minimum. A vertical line that runs through the vertex, which marks a center line or a point where if we folded it, the two parts of the parabola would touch. This is called the axis of symmetry. The point or points where the quadratic relation crosses the x-axis are called the zeros. So there might be 1, 2, or none. And the parabola is going to open either up, so it has a minimum, or down, so it has a maximum, and that is referred to as the direction of opening. So let's take a look at a few quadratic relations and look at these key features. So in this first one, the vertex for this parabola is over here. So the vertex is the turnaround point for the parabola. So this parabola continues on over here in both directions. And so it's moving up this way, hits the turnaround point. So the vertex here is at x is 3 and y is 1. So those are the coordinates for the vertex there. The axis of symmetry is this imaginary line that runs through there. So it doesn't matter what our y value is, our x value here is always 3. So our axis of symmetry is always going to be the equation of a vertical line. So it's always going to be an x equals, and whatever the x coordinate of the vertex is going to be our axis of symmetry. This parabola opens down. So our direction of opening is down. This particular parabola has a maximum value. So this is the highest point, and that happens when y is equal to 1. And the zeros occur over here and here. So they're also sometimes called the x-intercepts. So when does this parabola pass through the x-axis? So that happens at the point 2, 0 and 4, 0. So when we're touching the x-axis, the y-coordinate is 0. So we have 2 in this particular case. We'll do one more together. So over here, our vertex is at -1, -1. Our axis of symmetry happens here when x is equal to -1. This parabola opens up. The max or min here, we have a minimum value, and that happens over here when, when y is equal to -1. And our zeros occur here at -2, 0 and 0, 0. Oops. Okay, so the next thing we'll take a look at is a table of values, and we're going to graph and then label our following table of values. So when x is -2, y is 0. At -1, we have -5. At 0, we have -8. And at 1, we have -9. At 2, -8. 3, -5. And 4, 0 again. So here is our quadratic relation. Now these extend in both directions. So Our vertex is over here. That's this point, 1, -9. This happens to have a minimum value, so that happens when y is equal to -9. The axis of symmetry coming through is at x equals 1. This opens up, and the zeros over here are when y is 0, so we have -2, 0, and we have 4, 0. So you can try that with one more over here. And in a previous lesson, we looked at second differences, so we're just going to take the equation or quadratic relation we just did over here. So this is the same table of values. So for the differences, remember that we start with our second y value and we subtract the one that is above it. So I have -5 subtract 0, so that's -5. -8 subtract -5 is equal to -3. -9 subtract -8 is equal to -1. -8 subtract -9 is equal to 1. -5 subtract, -8 is equal to 3. And 0 subtract -5 is equal to 5. So now for second differences, we're going to do the reverse. We're going to start, sorry, not the reverse, but we're now going to subtract the first differences from one another. So once again, we can actually start at the very bottom. So 5 subtract 3 is 2. 3 subtract 1 is 2. 1 subtract -1 is 2. -1 subtract -3 is 2, and -3 subtract -5 is also 2. So you can see here that our second differences are all the same. So if our second differences are the same, then the relation is quadratic.